Welcome to iCode. This is the third video of the linked list implementation series. Today I'm going to explain you how to delete a node from an existing list, right? In the first video, we discussed how to create a single linked list, okay? Okay, let me show you. Here you can see a function called create, right? Then the second video, we discussed how to insert a new node to the list, right? In that video, we discussed three cases, right? Insert a new node as a first node. And here you can see a function called insert beginning. And the next case, we discussed how to insert a new node as the last node. You can see here a function called insert end. And finally, we discussed how to insert a new node as the specific position, right? Okay, today I'm going to show you how to delete a node from an existing list. Here also we have three cases, right? Delete the first node or delete the head node, and delete the tail node, and delete a specific node. Okay, according to our example, we created a list to store the details of books because we created a list for a bookshop. So now this is the list, right? A node is indicating a book, right? Because we created a list for a bookshop and we used the list to store details of a book, right? Each node indicates a book. Okay, now let's see how to delete the head node, right? The head node of the list is B0, right? That is book 0, right? The memory address of the head node is, you can see here, 090. Okay, to accomplish the task, that is delete the head node, I need a temporary reference type node. Okay, first I will create a temporary reference type node. Okay, let's see how to create a temporary reference. Okay, this is the function delete called delete first node. I'm creating a temporary reference type node and set it to the head node. Okay, now I have a temporary reference. It is pointing to the head node. You can see here like this. Okay, now we can access the head node by using both head reference and temporary reference, right? Okay, first we should move the head reference to the next node because we are going to delete this B0 node. After deleting this B0 node, the head node of the list is B1, right? In order to do that, we can change this memory address to 100, right, which is the memory address of the B1 node. Then we have a new link like this. Okay, now this link doesn't exist anymore. Okay, then what we have to do is we need to delete this link. Okay, we need to remove this link. In order to do that, we can change this memory address as null. Okay, now this link doesn't exist anymore. Okay, in this way you can delete the head node of an existing list, right? Now I'm going to modify the function delete first node, right? First I should move the head reference. Okay, this dot head equal to temp.next. You can use either temp or a head reference in this position, right? You can also use this dot head, right? But here I'm using the temp reference, right? It doesn't matter. Okay, now I'm going to break the second link. Okay, right, save the program. Now we have implemented the delete first node function. Okay, now let's see how to delete the last node of an existing list, right? The last node of our list is P6, that is book 6. The memory address of the last node is 600. Okay, in order to delete the last node or tail node, we need a temporary reference, and it will be pointing to the previous node of the tail node. The previous node of the tail node, you can see here, it is the B5, right? Memory address of that node is 500. Okay, let's see the function, right? First I will create a temporary reference type node and set it to the head node, and then, right, we need a while loop. I will explain about this while loop, right? First we will modify the function, then I will explain how it works. Okay, the condition is temp.next not equal to tail. Okay, then inside the while loop we can simply say temp equal to temp.next. It means we are going to move the temp reference through the list, right? Now I will explain the procedure using this diagram. Okay, according to the function we have a temporary reference which is pointing to the head node. Okay, then suppose the first iteration, right? The condition is temp.next not equal to tail, right? You can see here the condition is true. Temp.next equal to 100. It is the B1 node. It is not equal to tail. Then coming to the while loop and temp equal to temp.next. It means the temp reference is moving like this, right? The next iteration, the condition is temp.next not equal to null. You can see here the temp.next equal to B2, which is 200. It is not equal to tail. Then the condition is true. Therefore, the temp reference is moving like this. Okay, after finishing the while loop, the temp reference will be pointing to the B5 node, right? Because now the temp.next is equal to the tail node. Okay, so now we can access the B5 node by using the temp reference. And now let's see how to delete this B6 node, which is the last node of our list, right? First, we should move this tail reference to B5 because now we are going to delete this B6. In order to do that, we can change this memory address to 500. It means now we have a new link like this. As a result of that, this link doesn't exist anymore. Then what we have to do is we should delete or remove this link. In order to do that, we can change this memory address as null. Right now this link doesn't exist anymore, right? In this way you can delete the tail node of a particular list, right? Let's see the procedure of the function, right? After the while loop, now I'm going to create the green color link, right? This green color link. Okay, this dot tail is equal to temp, right? Now I'm going to remove the link I mentioned previously. Okay, I forgot to tell you, after temp node coming to this position, now the temp node is storing the memory address of the B5 node, that is 500, right? Okay, this way you can delete the tail node or a last node of an list of the list. Okay, now we will see how to delete a specific node, right? Okay, first I will explain you the procedure using this diagram. Okay, suppose now we need to delete the fourth node or fourth book of our list, right? That is B3. According to our list, it is B3. Okay, in order to do that, here also I need a temporary reference and it will be pointing to the B2, right? Before, okay, first I will create a temporary reference and I will be pointing it to the B2 node, right? Don't forget, I am going to delete the B3 node, right? Okay, let's implement the function. Right, now I am going to create a temporary reference same as previous and set it to the head node. Then I need another variable, type int, let's say I equal to 2. And also we need a while loop here. The condition is I less than the position. Okay. When we call this function, when we call this delete specific node function, we should pass some position as a parameter. Inside the while loop, we can simply say temp equal to temp.next. Right. The working procedure of the while loop same as previous. So now I'm not going to explain that procedure. After completing or after finishing the while loop, the temp reference is pointing to the B2 node, and we need in this case I need another reference, temporary reference, let's say next node. Okay, and that reference will be pointing to B3 node. Okay, you can see here another reference called next node is pointing to the B3 node, right? Now I'm going to create a next node reference, right? Node next node is equal to temp.next, right? Then in order to delete this B3 node, first we should remove this link. In order to remove this link, we can change this memory address to 400. Right now this link doesn't exist anymore, and we have a new link like this. And now we have a new link like this. The next step is we should remove this link also, right? In order to delete this link, we can simply change this memory address to null. Right now, okay, now this link doesn't exist anymore. Right, in this way you can remove a specific node, and we discussed or I explained about this variable in the previous video as well. Okay, now I'm going to create a green color link, right? This one. Okay, temp.next equal to next.next, and then we can write, or we can set next node.next equal to null. Right, save the program. Now let's see the output of this program. First, I'm going to call the delete first node function. Here you can see I have already called the delete first node function. Let's see the output. Okay, you can see here the right hand side the output of the program, right? After deleting the first node, the first book of the list is Moby Dick, right? You can see here after deleting the first node of the list is Uncanny Valley, right? The function, the delete first node function is working correctly. Okay, now let's see the output of the delete last node function, right? Let's see the output. Okay, after deleting the last node of the list is, you can see here, war and fees, right? Here you can see after deleting the last node, now the last node of the list is the Glass Hotel, right? Okay, now let's see the output of the third function. Okay, it means the delete last node function working correctly. Okay, now try to delete some node, right? I'm going to delete the fourth node of the list, or fourth book of the list, right? Let's see the output, right? Before delete the fourth book, right? The fourth book of the list is, you can see here, Hamlet, right? After deleting the specific node, right? the fourth book is, because I entered here, this position has 4. Now the fourth book is the Long Bridge River, right? It means the delete specific node function is also working correctly. Okay, this way you can delete a node from the list. And in the next video I will show you how to search a specific node from an existing list, right?